Okay, so in this lesson we will be graphing f prime, the derivative of f, given f, the base function. So here are some properties or rules, whatever you want to call them, for derivatives in relation to functions. So when f prime of x equals 0, you have a turning point, which are also known as critical points. That can either be a maximum, a minimum, or an inflection point. An inflection point is a change in concavity. So it can be a maximum, minimum, or an inflection point. So that the concavity never changes, that the same. This one, it goes from being concave up to concave down. So that's an inflection point. These are they're just critical points that are maximums and minimums. And then also two others. When f prime of x is greater than 0, f is increasing. And then when f prime of x is less than 0, f is decreasing. So in the following slide, you'll be able to visualize that better. Okay, so these are f, and then we're going to be graphing f prime. Okay, so as you can see, f is always increasing. That means that f prime will always be positive. So f prime, or f is increasing, so f prime is always greater than 0. So that means there will be nothing down here. Oops. Let me draw that a little better. So it's all going to be up here. So what you do to kind of sketch a graph of it, this is obviously not the exact thing. Like in the previous lesson, it's just estimating. We look at the slope at points. So you can sketch lines. So as you can see, that is a large slope, and it decreases. So the derivative of this might look something like this. Or it might even look something like this. Okay, let me change colors. It could even look something like this. We don't know exactly because we don't have, well, we do in this case, we have the function there, but we don't know how to, at this point, find the exact derivative. So it's probably one of these two, the derivative function. Okay, on to the next one. This is increasing, always increasing. So again, we can just kind of sketch our slopes. So that is, it's pretty much 0. Oh, and again, it'll not be any on the bottom. It's really close to 0, and then it gets big, and then it gets really big, and then it goes back down. So it'll probably, let's see, that's close to 0, so that'll be somewhere around here. Then it gets a little bigger, and then right here it's undefined because it's straight up and down. It's kind of hard to see, but it is straight up and down. So then you'll go back down. So that's just a sketch of that. And I'm going to pause one moment to check something real quickly. Okay, sorry, I was just double checking on that to make sure I didn't mislead you, but yes, that is correct. Since it's straight up and down, it's undefined right there for the derivative function. So then on to our next function. So this is similar to what you would do with a linear function. Sorry, we're going to pause once more. But while we pause, why don't you sketch what you think it would be? Okay, so now I'm back, and this, if you recall in lesson 1, linear functions are always what the slope is. So this is not a linear function, but it is, if you split up this side from this side, it is basically two linear functions. So this is decreasing, this is increasing. So that means that on this side, over here, there will not be any right there, and on this side, there won't be any over there. So since this is a constant line, and so the rate of change never changes on this side. So the slope of this, since we have that, we know that it's 1. So, or it would be -1 because it's decreasing. So that just means you do that. That's an open circle. Sorry about that. And then on this side, again, it's increasing, so it's going to be positive, but it's always a slope of 1. So you would go 1, open circle. Pretend that's a straight horizontal line. So that's what you get with this, because the rate of change never changes on this side, and then it never changes on this side. So although the two sides are different, that side is the same always, and this side is the same always. So now I have a few more on this page. So these are f, these are f prime. So the first one, x squared. So it's decreasing then increasing, so we won't have any here and we won't have any here. And it starts off with a really large negative, and then it gets slow, 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 and then it reaches 0, and then it goes big. So for parabolas, it's actually the derivative of x squared actually turns out to be just 2x, but you just should realize that for x squareds, it's always going to be linear. So on to the next one, x cubed. Let me change colors real quick. So we start off, well, it's always increasing, so we won't have any down here. I keep going over. Sorry about that. So we won't have any down here. And it starts off a really big positive, goes small, 0, and then small to big. So for x cubed, it actually turns out to be, the derivative of x cubed actually turns out to be 3x squared, but you should just remember that for x, it goes to squared. Like squared goes to just x. So we know that f prime is going to have just an x somewhere in there. We don't know what else is in there. And then we know for x cubed, there will be an x squared in there. We don't know what other constants or other variables there will be, but we know that it decreases by 1. So this is a good thing to realize, because when we go into the power property, you will be familiarizing yourself more with this. So then we'll just do our last one here. it's decreasing, so it's going to be negative. And then this one is decreasing as well. And it starts off really just slightly, almost 0, and then it gets bigger. So something like that maybe. And then this one starts off really big negative, and then just gets smaller. So it would look something like that. So this is the end of this lesson. In our next lesson, we will be talking about the definition of a derivative. This is not a property quite yet. Definition of derivative. It's not the properties yet, so this is kind of a lengthy process to find the exact derivative of a function. And with this topic, you'll be exploring limits as well, because you have to use a limit to use the definition of a derivative. So that's perfect timing for this lesson to end, because my battery is about to die.